Okay, so this is Node.js in 20 minutes, because that's all the time I've got. I do have this on GitHub. It's under stdr node 20min. I have to thank my wife who gave me the first pull request to fix all my typos. Thank you very much, Shannon. And what I'm going to do is give a code-focused introduction to Node.js. So this is kind of like the old C programming language book by Kernighan and Ritchie. It has code in it, but this is not excellent code. The code is designed to illustrate certain things you could do with Node. It is not good code you would want to use in production. So please, don't. So just a little quick intro to Node and some of the features it has. The sort of defining things for me, at least, are the fact that it's got streams, events, async I/O, and NPM, I think, is one of the killer features of Node. It's the one thing that I think makes this language really stand out. It does have like a TCP UDP support, buffers for I/O. JavaScript doesn't have anything like that. It is single-threaded. I think that's a wonderful thing because you don't have to worry about like semaphores and mutexes. And then you've got cluster if you need to scale up, and HTTP and HTTPS. You don't have to include another library or build your own requests. I like to think of it as JavaScript with additions. So this is the canonical Hello World example from the Joyent website. I've shamelessly stolen it. And when we run it, we just basically run node hello.js, and then would execute the program. And here I am testing it with the curl. So what's happening here is we require the HTTP library. And it's all written in JavaScript. You can see it in the Node resource library. And using that library, there's a function called createServer. And the thing it has is callbacks. So by default, without you doing anything, Node is callback oriented. So that's where the asynchronous nature comes from. Almost everything around Node is built around async I/O. And the reason that's really great is we can have things happen without sequence. So like languages like Python, Perl, PHP, C, they don't do async just automatically. And this can really help you, especially when you're doing I/O-based applications for server work. So the callback happens once the server is created asynchronously. So if you had another command down here, it might execute next. And then while this is setting up, then that series of functions would execute. And once something else called a scheduling function, then this would call back. So what happens here is this callback happens, and you get these two objects, request and response. And those are Node-ish objects for handling the HTTP request and response. And we're just creating a header. We're giving it a 200 status, and then a content type, and then we're just sending an end with a message. And then we use the returned object to have it listen, and then we bind a port, bind an address. So this one's only listening on the localhost address. Relatively makes sense? Cool. So there's some few conventions in Node. One is error first. So in the callback, like if you have a callback and it's going to return an error object, we put it first. I kind of like that because if you have an error, it's the first thing you want to handle. So what we've got is this read file, and if there is no such file, we would get the error object, and then we could just throw an exception. And if there was the file, we could just print it out. Here's another one that's using rename. The FS module in Node is probably the best one that sort of typifies the error first. Whoa. Okay. So pretty much error first. If you've got it, first thing you check for in a function, and you just handle it. The other convention when you're writing callbacks is the callback last. So again, the FS module, it has like a series of arguments. The last one is the callback. You see this in FS read file. You see this here in a net create server, and also in the listen. So one of the problems a lot of people criticize Node for is the nested callbacks. So people will often nest callbacks to do actions in sequence. Because if you just try to do these outside the callback, one would happen in the wrong order. So what you want to do is you want to basically, you have a callback. After the file is read, what we're doing, checking the error, and then what we do is we're doing like converting it to a string and then doing a replace. So what this function does is convert every var to banana in the code, the file that it's reading. And then after the fact, it writes it to the same file name with a new extension. And so what's happening is a nesting, and with just 3 functions, not too bad, but you could imagine if you had 12 or 20, it would become this big indented callback from hell. So there's a few solutions for that, and we're going to just take a look at them. One is the async module. This is like the first one I sort of learned. It's very intimidating at first. I actually prefer promises. We'll go over that next. But what this is doing is the same thing as the last one, but it is essentially, we're passing this function, waterfall, an array of functions to execute in sequence. So this way, if we had 20 or 30 or an arbitrary number of functions, then they would all execute one at a time. In this case, the waterfall, what it does is the output of each function becomes the input to the next. A little tricky, but it works very well for this little function we're doing. It's still, I think everyone, when they first look at async for the first time, has what the hell? It is a bit confusing. It's a bit complex. It's very functional. If you can think of any sort of asynchronous control flow, async can probably do it. But the same is mostly true with promises. So here's an example with promises. And I think if you look at it, you might think, this is a little cleaner. I'm not as good with promises, but I do generally like them. I like the Bluebird a little bit better in Q. A little faster, but also it's a little simpler. Now, one thing that it has to do is Node is a callback-based interface. So it has to essentially promisify what parts of Node you're using so that those functions in this module will now return promises. So here, what we're doing is we're using the promisified read file async, and then we have a then. So this is what happens afterwards. And then we have another then. So this is what happens after that. And then it makes a sort of declarative model that's easy to follow. So what promises does, I think it makes it a bit easier to read async code. Any question? Yeah.
So, I mean, if you're doing everything in series, why wouldn't you just do it synchronously?
Well, you could do synchronous code, but I think what we're trying to do in Node is we're trying to take advantage of performance. So if we're doing something in sequence, let's say we're going to do something I/O-based, which is usually what servers do. There's a long latency to read a file and then wait for the results.
Right, that's a good point.
So what we try to do is we try and like start the reading asynchronously and then do something else. Otherwise, like let's say we had an 8-core system and they were all reading a file at the same time. You got to wait all that time to get the stuff from disk and then get it back. So, and that's the advantage of Node. So even if you're using 1 core, we can start doing a lot of asynchronous actions and just take advantage of the fact that they're going to take a long time to complete and just get a lot of stuff done. And that's, I think, one of the beauty of Node is it was written to do async I/O. But it also, if you're not really using a good sort of flow control library, can be a negative. So I highly recommend if you get into Node, pick one style of flow control library and just start using it. So we're going to do streams in 2 minutes. Yeah. There is a lot of stuff I'm not going to tell you about streams. Basically, it uses events to pass data, communicate errors, signal things like the end of the stream and the input. Data is passed by using buffer objects. Streams can be readable, writable, or transform streams. So if you wanted to change an encoding scheme from one thing to another, you could write a transform stream. Readable streams can be piped to writable streams. So you can make a sequence or chain. So if you wanted to do, like, essentially, we have some code here that actually takes the input from one API and just streams it to another, so we don't have to buffer. And that's a huge advantage of Node. A lot of people talk about back pressure in servers from buffering if an API is too slow. With the streams, you don't really have that significant problem. Streams have an API, and methods to implement them, so you can actually create your own stream. Again, a kind of cool thing to do is the transform stream. So if you wanted to change an encoding or change a request or mutate something, streams are a great way to do that. This example shows reading from a stream. So here's like a function, and it's got like the HTTP request object. Now you could actually use this in that hello world. Let's say if we wanted, that hello world didn't really do anything useful. It just responded to every sort of HTTP request with just hello world, ignored anything that was coming in. If we actually wanted to read the data from the body, we could actually write this. So what we would do is start a little string, have an event that would capture the data. And by the way, I'm really nervous that Forrest is looking at this. This guy really knows a lot about Node. He's right up here.
I'm just so
And then we have like an end, a signal. There's a lot. Again, these are illustrative. These are not all the events you would want to handle. This is just to give you a sort of flavor and idea. Again, illustrative. So what we're doing is on the end event, then we've got it, and then we can have a callback and pass the body back. The reason I put undefined is because normally we have a convention of error first. If there was an error event, and in the case that I received an error event, then I would pass a callback with an error. So that was how you would collect the body in the hello world. So you could actually combine these two and have something that did something almost useful. OK, here's cluster in 2 minutes. If you ever used Unix or done some Unix C programming and you use fork exec, it's kind of like that. Otherwise, it's just magic. The master basically is forking the child processes, and I'm really hand-waving a bit here. Each child process calls listen in Node, but the socket and listening is actually not happening there. The master is actually managing that I/O and then sending the requests to the children that are listening to that port. I believe children can now listen to different ports, and all the children have to listen to one port now. Events can coordinate the master and the children. There's also listening, disconnect events, exit, and setup. I think that's it. And basically, there's a message passing API. So the children can communicate and coordinate sort of out-of-band information with the server. When you have, yes?
So why do we want to use cluster?
Well, if you did not use cluster and you had like a single-threaded thing, it would be hard to take advantage of all of the CPUs. So if you basically did not use cluster and you're doing like a lot of activity, your other CPUs would be sitting mostly fallow. Now, there are some threads in Node and in libuv, but OK, we don't talk about, forget, there are no threads. Node is entirely single-threaded. But if you didn't use cluster, those other CPUs wouldn't be doing anything. So normally you'll see, like standard Node programs, you'll see like some piece of code that'll be forking. There's the process object will tell you how many cores. You usually see a for loop forking once for every core. That's not exactly right. Sometimes you really need to look at your application and figure out how much you can take. These things are mostly doing I/O. They're not typically doing CPU-bound activity, so usually you can overload them a little bit more. So here's a little simple cluster example. If basically we have like the cluster object will tell you if it is a master or a worker. And so if we're in the master, then we're going to fork off just 3 forks. And we have an event for listening. So once the workers are there, then we just say that this worker is listening. And here's what each worker will do. So because if we're not a master, we are a worker. They each one create a server that's listening on a port, 8000. And each one will then, the master will just print out each one that's listening when it gets the event. There are other events too. This is just a little thing, and it sets up a little HTTP server with 3 workers. So each one would say hello world when you made a request. And if you did this, you might notice a bug where one of them is answering more than the others, which I'm waiting for the next release that has that fix.
Excuse me.
Yes?
When you connect that port, the 8,000, so all three workers here will listen on 8,000?
Okay, sort of like virtually they're all listening, but actually there's only the master process is actually listening to that. And then dispatching the requests, in theory, round robin or randomly, but there's a bit of bias right now.
So does that mean that you are still limited by the master process? Or?
If the master process was doing a lot of CPU, that would be a limiting factor to what you could do in terms of number of transactions. But it is a limit in how much it can dispatch to the others. But normally that's not a problem because the I/O dispatching is very cheap. And then here's what the output of that last program would be. Essentially a type node cluster, you'd see workers, each worker's listening. They won't necessarily appear in order because it's not sequential code, it's asynchronous. And if you did the requests from the command line, you might see something a lot like this, which I'm waiting for that bug to be fixed.
2 weeks.
Okay, 2 weeks. Yay. Okay, so here's a quick example of TCP sockets. So again, almost all this function, the really cool thing is if you look in the node, almost all this functionality is in JavaScript, but dependent on functionality within the C++ container. So here we're creating a server, and this is not an HTTP server, it's just a TCP server. And this is the listening, I think they call it the listener. And what it does is I'm just doing a little hacky thing. It's a hacky little chat server. So I take basically I have an object, and then I take the file descriptor and use that as a property. This is very hacky code. Please don't do this. Okay, I don't know why that's happening. So then basically what I do is I disconnect when there's an end event. And then on a data, what I'm doing is I'm displaying whatever was read in to everyone but the current socket. So it makes a little poor man's chat server. And here's where we cause the server to listen. The neat thing, the reason I really like this is it gives you a lot of boilerplate. Like I'm a C programmer, was a C programmer for many years. Doing all this functionality that I'm showing you that can be done in a few minutes would take, a few hours. So the time savings using a language with a lot of baked-in functionality is significant. Here is something with UDP. I'm actually a big fan. I don't think UDP is used enough. It is unreliable, but within like one LAN, it's entirely safe. Assuming you're not overloading your routers or anything. So again, we have it's event-oriented. So this thing shows how UDP is not server-oriented. Each socket can be listening and sent. So we create the socket here. We use UDP4. And then on messages, we have a little callback to asynchronous to say what we received. We have to bind a port so the socket can listen. And here, I'm just to demonstrate it can do something useful. I use the JavaScript set interval. In this case, it's the node set interval function. And basically, here's the example of the use of the buffer object. And I just send hello world to the socket. How are we doing on time?
5 minutes.
I got 5 minutes and I can do this. So one of the cooler things, and I think, Forrest, is domains, are they staying?
Nobody knows.
OK. I like domains, and as long as they're there, I'm going to use them. Forrest actually gave a great talk on domains with Express. I highly recommend if anyone can dig it up. It was fantastic. So if I use try and catch, and I will never see this catch. And that's just how it works, because this little exception event won't be caught by this because it's going to happen in a callback. And that callback has nothing to do with what this try and catch will catch. And it just doesn't work with async. So the solution is domains. Domains in 2 minutes. You can't catch errors using async, like I said. Global uncaught exceptional handlers exist in Node, but they're clumsy. Don't recommend them. You just want to exit if you've got an async error. And it would be awesome to have an error handling that could cover part of your code. and that is domains. Here's an example of a domain. So again, the functionality required, we create a domain. And this is the really neat thing I like about all of Node. Very simple APIs that are easy to communicate, easy to use, easy to pick up. So we have an asynchronous error event that we can catch, and then we can say error caught by domain. And then what we do is we basically run some code within the domain. This isn't the only way. This is just a way to do it. And again, what I do is in a callback, after some period of time, I throw an exception error, and this will be caught here. And that's kind of neat. So if I could have like if I had an Express or Happy.js API, I could like set areas or routes or like URI paths to handle these asynchronous functions. And it doesn't matter what through, I could handle that and give a sort of cogent response to the client. Maybe it's just 500 error, but it's going to be bubbled up. So that's it. I made it in time. So you want to do something that's not node specific, like a sequence of actions that could be run in a browser?
Right. So like I didn't want to do like all of like the export stuff or.
Okay. So what you could do is you could do something like Browserify along with like say Q or Bluebird, and I think async also runs in browsers as well. And then you could just basically use the flow control, like the two examples I went over. And if you had something that was node specific, you could wrap it in an API. Does that?
Maybe a better question is there a good example?
If you okay, I can't think of an example, but some of the code that I have on the GitHub, and I can point you to it, sort of typified flow control that isn't node specific.
There's a whole Node School module for
Oh,
async.
that's right. That's right.
So if you go to nodeschool.io, which I highly recommend that everybody here do, there's nobody in this room who cannot learn something from Node School.
Yeah.
There is a whole module on Node School for working specifically with the async module. It gives a lot of examples for things like waterfalls and series and all those things to make clear when you might want to use which.
And async's a good one, but for some people, the first time they look at it, it can be really confusing.
I think there's one for promises now too.
Yeah, that would be. There's also a good Node School one just for beginners, and all the Node School ones. They're all on GitHub. I think you can just search for Node School.
And like I said, Node School.io has all of them.
Right. Forgot that.